we have a question that says find the derivative of the function y is equals to 2x squared 2x minus 1. Alright, at the point x is equals to minus 1, a says 18, b says 16, c says minus 4, d says minus 6. Now the first thing I'm going to do is to find the first derivative of this function 2x squared 2x minus 1. So let's write solution. Alright, so the solution becomes dy over dx of this function. Let's write 2x squared 2x minus 1. So that's the first derivative, right? That's the first derivative. Now we have 2x squared 2x minus 1. We can expand it by using 2x squared multiplied by inside brackets. So if I expand that, we're going to obtain 2x squared multiplied by 2x. That's giving us 4x cubed minus 2x squared minus 1. That's the same thing as 2x squared. So this is now our expanded expression. Alright, so now when we have an equation like this, alright, and we are told that we have to find the derivative of this equation, we are going to find the derivative of each individual term which contain x, or each individual expression which contain x. That's I'm going to find the derivative of 4x cubed, I'm going to find the derivative of 2x squared. Now generally when you have d a x raised to the power of n, alright, over dy, you are asked to find the derivative of a certain expression a x raised to the power of n. So this will be equivalent to a multiplied by n, then multiplied by x n minus 1. So use n, which is the power of x, to multiply a coefficient of x, which is a, and then you are going to remove 1 from the power of x, which is n. So you are going to be left with a times n times x to the power of n minus 1. So alright, let's do that for 4x cubed. So the 4x cubed divided over dy, this will be equivalent to 3 times 4 is 4. If multiply 3 by 4, that gives 12. Then x, 3 minus 1, that gives 2. 12x squared. Let's do the same for 2x squared. Yes, so we have the 2x squared over dy, which is now equals to 2 multiplied by 2, that gives us 4. If you remove 1 from 2, of course, you're going to left with x. So let's write out the expression. So this is now equals to 12x squared minus 4x. So this is now the first derivative. So you can say y is equal to 12x squared minus 4x. This is the first derivative of this expression. Now they said at the point x minus 1, so we're going to find the value of y when x is equal to minus 1. So we just simply say that y now becomes 12. Impute back minus 1, that's minus 1 all squared minus 4 open bracket minus 1. Alright, so this is also equals to minus 1 all squared at the same time it's minus 1 times minus 1, which is plus 1. So that's going to give us plus 1 times 12, that's 12. Minus 1 times 4, that's plus 4. Negative, that gives positive. So 12 plus 4, we have left 12 plus 4, yes, which is equivalent to 16, which is option B. Question 2 says differentiate sine x minus cos x. Now, as we did for minus x cos x, as we did for question 1, we're first going to find the first derivative of sine x. I'm going to find the first derivative of x cos x, and then we're going to combine both and see which option our answer tallies with. So let's go with solution. So the first thing we're going to do is d, alright, sine x over dy. Now, based on standard table of values, the first derivative of sine x, you should know that is given to us as cos x. The first derivative of sine x is cos x, but meanwhile the first derivative of cos x is minus sine x. Alright, as for x cos x, we have d x cos x divided by dy. Now for the multiplication of two different entities which both contain x, you use what we call the product tool. So for this, to solve this, we're going to use the product tool. Now, what does the product tool tell us? What does it entail? The product tool is that whenever you have, let's say you have two terms, like here, two entities which contain x, u and v. To get the derivative, the first derivative, you are going to take the first derivative of u multiplied by v, then you're going to add what you get to the first derivative of v multiplied by u. So we are interchanging your derivation techniques, alright? Changing from u to v and then adding your answers, alright? So first off, what is the first? Let's do it for x cos x. We'll now see that x cos x, where u is equals to x and v is equals to cos x. First derivative of u, which is x, first derivative of x, that's 1. So we have 1 multiplied by v is cos x, plus the first derivative of v. Now, we said already that cos x, the first derivative is minus sin x. So let's put that in brackets, minus sin x, which are going to multiply by u, and u is what? X. So let's multiply this together. We're going to have cos x minus sin x times x. That's plus and minus will give you minus x sin x. So we have cos x minus x sin x. To obtain the derivative of both entities, we're going to combine them. For sin x, we obtain the first derivative as cos x, then we had minus. As for x sin x, we obtain derivative as cos x minus x sin x. Alright, now you are going to use this minus negative 1 to open the bracket. So we have cos x minus cos x minus sin minus, that gives plus x sin x. Now cos x minus cos x, that is equivalent to 0. So what you have left is x sin x. That's given to us as our final answer. 3. Find the derivative of y is equals to x to the power of 7 minus x to the power of 5 all divided by x to the power of 4. Now, because there is a common denominator to both x to the power of 7 and x to the power of 5, I can do a simple trick that enables you to solve this fast. Alright, first off, I'm going to split it. This fraction is the same thing as x to the power of 7 divided by x to the power of 4 minus x to the power of 5 over x to the power of 4. Now, from indices, we're going to remove 4 from the powers on top. Why? Because they have a common base and we can subtract their powers. So if you do that, 7 minus 4 is equivalent to 3. You're going to have x to the power of 3 minus 5 minus 4 is equivalent to 1. Now, this is now our broken down expression simplified. Then we can now use the formula we did for question 1. Remember, we said that d, when we have a power of x n dy, this is equivalent to a n x n minus 1, right? So let's implement that here. For x cube, doing it for x cube, we have that 3 multiplied by, remember this coefficient here is 1, so that's 3x. If you remove 1 from 3, that gives 2, alright, minus the power here is 1 times coefficient remains 1, but 1 minus 1 is what? Now it's 0. So everything here is going to give us 1 as our final answer.